One of the essential calculations that we do in vectors is the scalar product, or it's sometimes called the dot product because we use a dot to represent the operation. So this is taken from the Math AA IB data booklet, just to give you an insight as to what the formulas look like. They have written them for 3D, but obviously it can be easily adjusted to 2D. So make yourself familiar with the notation used in the data booklet. So what is a scalar product? From the name itself, we are going to take the product. So we're technically multiplying some numbers, but the result is going to be a scalar. It's going to be a real number. So if vectors are given in what we call the component form, so if you know the actual components of the vectors, then the scalar product is just simply you multiplying the components together, the corresponding components, and then adding the result. So I am multiplying the I components together, and then the j components together, and then adding the result, and it should give me one final number. This is the easiest and most basic definition on how to find the scalar product. Now, there is a geometric definition as well, and this becomes useful in case you do not have the component form of your vector, so you don't have these components. So if I have two non-zero vectors a and b, then the scalar product can also be defined as taking the magnitude of a and b and taking the cos of the angle between the two vectors. So this is what we do. And obviously, looking at the two equations, I can rearrange them. We'll do some questions where some values are missing and so on. Keeping in mind that the angle we're considering most of the time is between 0 and 180. We'll talk more about the properties in the next lesson. So just quick examples just to get us started. If I need the scalar product of these, you can write them out any way you want. So the scalar product is just going to be me taking the coefficients of the I components and multiplying them together. So 2 and -1. Add to that the j component, and that's -1 and -4. I like to put my brackets in there and intentionally put the plus in there just so that I don't accidentally make an arithmetic mistake and then lose unnecessary marks. So this will just simplify to a 2. So the scalar product of these two is just a 2. If in this situation you're given another different type of information, you're meant to find the scalar product, you don't have them in component form, but we have the other formula using cosine. So I know that if I need the scalar product, it's also the same as taking the magnitude multiplied by cos theta. So I have 3 times 5 cos pi over 6. This is where you're expected to see these questions in non-calculator papers. Cos pi over 6 will just give you a root 3 over 2. So you have 15 root 3 over 2 as the final answer. So that's the scalar product. So it's fairly simple how to do the scalar product, but do have a look at the different questions. So if now we're combining, we're going to combine the different definitions. So we have this first definition and this was the other definition. And if I combine them together, I can actually use them to find the missing angle, for example. So cos theta will just be you taking the components multiplied together divided by the magnitude of each vector. And if I need the angle, I'll take the cos inverse of that. Obviously, all of this can be extended to 3D, which is what is written in the data booklet. So let's try it with some examples. So the first one expects you to use a calculator. Second one is without a calculator. Notice how it says exact value. So let's start with the first one. I need the angle between them. So I know the formula is going to be to find the angle, I'll need to take cos inverse of the scalar product in component form. So I'm doing 1 times minus 1 plus 1 times 3. So this times this plus this times this. And all divided by, I'll take the magnitude of A, which is 1 squared and 1 squared, and the magnitude of B, which is negative 1 squared and 3 squared. Simplifying this, so I'll skip some of the notation, some of the arithmetic. You get 1 over root 5, and then cos inverse of that is 1.11. That's the 3 significant figures. Make sure you're in the correct unit. Now for part B, same exact idea, it's just that it's a non-calculator type question. So I am multiplying the components at the top, root 3 and 2, and 1 and minus 2 root 3. And then I'll take the individual magnitudes, so negative root 3 squared plus 1 squared, and 2 squared, negative 2 root 3 squared. Obviously the negative doesn't matter here, but I like to write it there just so I don't get confused with the values. So this will overall just simplify to a negative root 3 over 2. Now this is where your knowledge of trigonometry will be helpful. If you have a calculator, it will give you the correct angle. But without a calculator, you should know that cos is negative in the second and third quadrant, but we're not going to consider the third quadrant because we are only considering angles between vectors to be from 0 to 180. Again, we'll see that with the properties next lesson. So I'm only looking at the second quadrant. The first quadrant solution is the first quadrant solution is pi over 6, which means that the second quadrant solution is just pi minus pi over 6, which is 5 pi over 6. That's the final answer. And then our last example, if I have these vectors, so this time the question is just there because it's in 3D. So the scalar product is just going to be me multiplying all the numbers there. So I'll take the 2 and the 1, and then the 3 and the 2, and then the minus 1 and 4. Simplify all of that, you should get 4 in there. Now part B says you need the angle in radians between vector A and B. We can use the answer from A to help us. It will save us a lot of work. We know that this is equal to the scalar product and component form at the top and the magnitude of each. So I know what the numerator is, and then the denominator is just a long square root. So you have the 2 squared, 3 squared, minus 1 squared, and then the other magnitude is 1 squared, 2 squared, and 4 squared. So the full thing is going to simplify to 4 over 7 root 6, which as a value gives you 1.34 radians. That's the 3 significant figures. So hopefully the questions are fairly straightforward and easy. Next lesson we're going to look at properties. What does it mean to take the scalar product? How can we use it to our benefit? What are some special numbers that could come up from a scalar product?